This video is about the fluid mosaic model of the cell membrane. It's called a fluid mosaic because the model proposes that the proteins in the cell membrane are like a mosaic floating in a lipid bilayer. Let's take a look at the lipid bilayer. It is composed of phospholipids lined up like so. A phospholipid has a head that contains a phosphate group and has a separation of charges within it. There are two tails. One tail is made of saturated fat and the other tail is unsaturated. The tail of saturated fat has double carbon bonds. Therefore, there is a bend because it's a bent shape. The bends in the phospholipids keep them in this structure and prevent them from clumping up. That being said, if a certain cell membrane has more unsaturated bonds, that membrane will move more easily and won't be as rigid. This is known as fluidity. Fluidity is what causes the cell membrane to be selectively permeable. This means only specific molecules are allowed to pass through the cell membrane and some substances get through more easily than other ones. Remember how we said that the head of a phospholipid has a separation of charges? That means the head is polar and the tail is nonpolar. Polar substances are hydrophilic, which give them a tendency to interact with water. That's why the heads are towards the cytoplasm or exterior of the cell membrane, because outside the cell is a hydrated environment. The tails, however, are nonpolar and therefore hydrophobic, which give them a tendency to avoid water. Therefore, substances that are hydrophobic can go through the membrane because they can make it through the hydrophobic middle. Hydrophilic substances that attract water cannot pass through the membrane easily because the interior of the membrane doesn't like water. One function of the protein molecules in the fluid mosaic model is to help hydrophilic substances get through the cell membrane and into the cell. That's all for this video. Thank you for watching and good luck studying.